Welcome everyone. Today we are diving deep into Databricks Lakeflow, the evolution of declarative pipeline and engineering at scale. This is the latest version of Lakeflow, which means we'll be covering the latest features and best practices that are transforming how we build a data pipeline. My name is Ahmed Mahmoud from DataMindAI, and we'll do a lot of this work for Lakeflow. So what we are looking at here is the complete Lakeflow ecosystem represented by three core components or pillars. On the left, we have the ingestion with Lakeflow Connect. This is your gateway for bringing data into the platform, like data from outside, from the source to the platform. In the center, we have transformation with Lakeflow Pipeline. This is where the magic happens with your Python-based declarative pipeline. And on the right, we have the orchestration with Lakeflow Jobs, ensuring everything runs reliably and on schedule. The key message at the bottom is crucial. We are transitioning from imperative notebooks to declarative files. This represents a fundamental paradigm shift in how we approach data engineering. Instead of telling the system how to do something step by step, we are now declaring what we want and letting the intelligent engine figure out the optimal execution path. This shift is not just about syntax change. It is about moving from a manual dependency management, error-prone orchestration, and fragile pipeline to an intelligent, self-optimizing system that handles the complexity for us. The key takeaway here is Lakeflow is a unified solution for the entire data engineering lifecycle. It has three pillars: Connect for ingestion, Pipeline for transformation, Jobs for orchestration. Represents the evolution from notebooks to production-grade engineering. It focuses on declarative over imperative approaches. Now, if you look into details on these pillars or components of Lakeflow, we will see much more clearer picture. Let us break down each component of the Lakeflow ecosystem in details. For example, starting with the Lakeflow Connect. This is your intelligent ingestion layer. It provides the native connections to databases like SQL Server, MySQL, and enterprise applications like Salesforce, Workday, and ServiceNow. What makes this powerful is that it is a powerful and it is powered by the latest technology utilizing change data capture or CDC. This means you are not doing full table refreshes constantly. You are capturing only the changes as they happen, which is far more efficient and scalable. And moving to the right, which is the Lakeflow, or to the middle, sorry, the Lakeflow pipeline. This is the heart of the transformation layer. It is built on the foundation of Delta Live tables, but it is evolved significantly. The key innovation here is declarative pipeline using Python files. The engine automates three critical aspects. Orchestration, incremental processing, and compute auto-scaling. You declare what tables you want, what quality rules to apply, and the system figures out the execution graph automatically. No more managing DAGs manually. Finally, the Lakeflow Jobs. This is your orchestration layer for every workload. It supports the triggers for event-driven architecture, branching logic for complex workflows, looping for iterative processes, and provides full lineage tracking. You can see exactly where your data came from, how it was transformed, and where it is going. The red text at the bottom captures the essence perfectly. This is one unified solution, replacing the need to stitch together fragile middleware. No more custom script holding your architecture together with duct tapes. For example, everything is integrated, intelligent, and enterprise grade. The key takes the key take points here is like the Connect is native CDC based ingestion from diverse source, and the pipeline is declarative transformation with automatic optimization, and the job is comprehensive orchestration with lineage tracking. It eliminates the need for multiple point solutions. Now, let me show you what does it look like in the Databricks, because some of you probably might have trained with Databricks, and also might have seen like Databricks webinar or attended summits and so on. So you might have seen these pictures for the Lakeflow. So what I want to say is like what I'm present to you is the same as what is in the it is based on what Databricks offers basically. So for example, this one is the Lakeflow Connect, the one of the pillars. So it is mainly used for ingestion, bringing data from sources, from outside source to the platform. And we deal with the data which are in Oracle, for example, or Microsoft SQL, or PostgreSQL, or MySQL. It could have also Workday and also ServiceNow, SharePoint. So it can connect with different kind of sources, different kind of databases, and then brings the data and take it into the intelligent data platform. Yeah. So that's the key part. So this is the ingestion side of it. And the second bit is like the declarative pipeline, which is Lakeflow declarative pipeline. And this is the transform side of it. And here, it is very important to look at it from point of view of the Medallion architecture, where it segregates the data into 3 buckets and 3 areas, depending on the quality of the data. For example, you have the bronze layer where we put the raw data, the copy of the source data, the truth of the truth of your data set. That is because it's the truth, because sometimes it's confusing here, because it's a copy of the source. It's exactly the same as the source. That's why it's called the truth. The truth, of course, is the source of the data, and this one is like a copy of it. Yeah. So that's the bronze. So what you do is like you take when you try to clean it up, what you do, you take a copy of the data or the table or the file, and then you deal with the copy and not with the original. So the source will be like immutable. You don't change it, you don't touch it, but you take the copy and do some work on it. You enrich it, you clean it or transform it, and therefore will be useful. And then you can aggregate it to make it like you send it to the gold layer. So as the data goes from bronze to gold, it becomes like it have cleaned, validated, and then business logic applied into it, and then become ready for business for consumption. Yeah. So that's the second element, which is transformation, or the second pillar. The third pillar or component of the Lakeflow is the job, which is very important here as well. It orchestrates the work itself. So it have like trigger. The trigger could be like whether new file arrives, or it could be based on a timeline, scheduled time, or it could be like other things which can trigger the job itself. And then you have this orchestration mechanism with the control flow, and then using the serverless compute as it goes from end to end. So you have the orchestration from end to end solution here, which is done by the Lakeflow Jobs. Yeah. So that's is similar to what Databricks are offering, or what I have done is like I based my presentation here on the documentation and of course the the logic which Databricks is providing, and just adding my experience on top of it and present it here. So now this slide now illustrates the fundamental difference between the old way and the new way of building data pipeline. I love the analogy here. Imperative is like following a recipe, while declarative is like ordering from a menu. Like any recipe is you buy, if you want to make food, for example, you have the recipe for the specific food, and then you add them in specific order, and you do like the cooking in a specific way, and then it becomes food and it be consumed. So, but the declarative one is like having a menu. So you choose from the menu what you want, and then the chef will do it for you and bring the food ready for consumption. So on the left side, we have the imperative approach, which is essentially the recipe. You have task 1 for reading, for example, task 2 for transformation, and task 3 for writing. Yeah. The problem, you are responsible for defining the execution order, managing dependency manually, and handling retry logics, and dealing with all the complexity. Look at these messy arrows. That represents the tangled web of dependencies you have to manage yourself. In code, this looks like spark.read, then df.write. You are explicitly telling the system every single step. On the right, though, we have the declarative approach, the menu. You define your source table, your intermediate views, and your final table. The engine determines the graph automatically. You use decorators like @dp.table and @dp.materialized_view. The beauty is that you are just declaring what you want, and you want this table, you want that view, and the engine figures out the optimal execution plan, handles incremental updates, and manages dependency, as well as scales compute resources as well automatically. The key message here is stop writing the recipe. Start ordering from the menu. Yeah, this frees you as a data engineer to focus on the business logic and data quality, not on the plumbing and orchestration side of it. The key takeaway here is the imperative is manual dependency. When you say the imperative is like manual dependency management, error prone and rigid, while the declarative is engine managed optimization, automatic DAGs generation. Focus shift from how to what reduces cognitive load and maintenance burden. Yeah. So now you might see this warning message at the top and think, oh, my notebooks are legacy? Well, yes and no. Let me explain the small area here, the small bits which you need to understand about this notebook and file kind of thing. Yeah. So notebook are becoming like legacy, and file is becoming like the one we need to go, or the fad, as it were. Yeah. But here is like the key element for our data engineering, the files and not the notebooks. But again, it's not like a clear cut here. So, for example, notebooks remain fantastic, yeah, for what they were designed for. Interactive exploration. They are perfect for ad hoc analysis, data discovery, quick prototyping, and sharing results with stakeholders. But here is the reality. They were never designed for production data engineering at scale. Yeah. They are harder to modularize and test properly. They don't support traditional CI/CD workflow well, and they are great for experimentation but poor for robust pipeline. The latest standard, which is 2026 standard, is now Python.py files. That's the standard. That's what you call the file, the .py files. This is the production-ready approach. Why? Because .py files enable modular software engineering practices. You can structure your code into logical modules, create proper test suites, and integrate with GitHub Action or Azure DevOps. Support complex directory structure, and use standard Python functions and imports. Yeah. The key principle at the bottom says it all. Notebooks are for exploration. Files are for engineering. For production pipeline, the ones that need to run reliably at 3 a.m., that have SLAs, that power critical business decisions, you want the rigor and structure that .py files provide. You want version control, yeah, that shows actual diffs. You want CI/CD pipeline that can run automated tests. You want code that can be packaged, deployed, and maintained by engineering teams. So don't throw away your notebooks. They are still valuable for the right use case. But for the production data engineering, it is time to embrace .py files as the standard. So the key takeaway here is notebooks, best for exploration and prototyping. Files, best for production engineering. Enables proper software engineering practices, supports CI/CD, testing, and modularization. So the 2026 standard emphasizes engineering rigor in here. Yeah. So that's what we meant by file. Now, this slide is your quick reference guide for the syntax migration. If you have been using Delta Live tables with the DLT decorator, you need to update to the new standard. Yeah. First, the import statement changes. Instead of import DLT, you now use the from PySpark import pipeline as DP. Now, the important here is that DLT was proprietary mechanism, while the new one we are using, as you can see, PySpark, which is the open source. So it's a shift from a proprietary one to the open source as well. So that's a change which is happening here. So the DLT is being replaced by the PySpark import pipeline. They are doing the similar functionality, but now it is the PySpark who's doing the pipeline. Yeah, so we are using it from the PySpark. This is more than just a cosmetic change. It represents the evolution from Delta Live tables, which is DLT, to the broader Databricks pipeline framework. Now, for streaming tables, the old at DLT.table decorator with the streaming parameter becomes at DP.table. Notice it is cleaner and more intuitive. Yeah. For batch processing, the at DLT.table now becomes, now this is very key, this is a change here. It's not no more a table. It is at dp.materialized underscore view for batch processing. Yeah. This naming is actually more semantically correct. A materialized view is exactly what it is, and a pre-computed stored result of query. Yeah? So for the data quality side, for the data quality expectations, yeah, the decorator changes from at dlt.expect to at dp.expect. There is no change apart from the DLT now is DP now, right? Because Spark is coming from Spark. Yeah? The concept remains the same. Defining quality rules for your data. That's what it is doing. Yeah? For the CDC flows, the old DLT.apply underscore changes becomes, this is critical now, it's changed, the name is different now, dp.create underscore auto underscore CDC underscore flow. So the name, well, this is better name in the sense it describes better what it's doing. So the new name better describes what it does. It creates an automated CDC flow that handles insert, update, and delete. The red warning box on the right is critical. Now, the pipeline module is only available in a pipeline context. This means, yeah, this is important here. The pipeline module is only available in the pipeline context. This means you cannot use .collect, .save, or .count inside the dataset definition. Yeah, these are action methods that would trigger computations, but in declarative pipeline, you are just defining what you want. Yeah, you are not action. This is define what you want. Yeah, the engine handles when and how to compute it. Yeah, this is common problem for people transitioning from imperative to declarative code. Now, the key takeaways here is new imports. The new import is PySpark.pipeline, yeah, as DP. The clear semantics with new decorator names. Context-aware execution model. Avoid action methods in definition. Use the table for quick migration reference. So the table here, as you can see, you can use it for, it's very helpful to see what in the old, the DLT syntax and the new one, the SDP syntax look like this, the PySpark versus the DLT one. So, so as you can see, the import is different. As I said, so this is the key part. It could be taken from Spark. And then the streaming is the same. The batch is different. The batch now it uses materialized view, and the quality is the same, but the CDC now is like dp.create underscore auto underscore CDC underscore flow. Now let us dive now into the first core construct, the streaming table. Yeah, let's just a little bit more details now. If you can, if it is too much, just have a coffee, get a break, and come back to look at it here. If you are is okay, you can continue using it, because you are going to look at in a slightly different way now. It's a different angle. It is a similar thing we are talking about, but we are looking at it from different angles here. Yeah. So now the streaming table. This is a continuous incremental data ingestion. Now, if you look at the code here, what we are using is, as we said before, at dp.table. Yeah, decorated. The decorator is at dp.table with a comment. The comment here is raw data from AWS3, which is AWS S3. Yeah? And setting table properties. In this case, that what the property is bronze, making it as bronze quality. Yeah. Making as bronze quality, which is important for Medallion architecture. Yeah. Now inside we define the function called. So this is a decorator now. The function is raw data that returns. The raw data function returns a Spark read stream. The key feature here are cloud files format with the JSON option and the path to our sources. Yeah. So this autoloader functionality is incredibly powerful. On the right, you see three key characteristics of this function. Yeah. Three key characteristics of here. Number one is, the first characteristic is it creates an incremental append-only table. Yeah. append-only table. This means new data is continuously appended without reprocessing everything. This is essential for efficiency at scale. The second bit is the second part is like it processes only new data seen at the last checkpoint. So it will have a last checkpoint, and then it can only process data since that specific last checkpoint. The engine maintains checkpoints information, so it knows exactly where it left off. Yeah. So if your pipeline fails and restarts, it picks up the right where it stopped. Yeah. It picks up from the place where it stopped. Yeah, because there is checkpoint information within the system. Yeah. So it picks up where it stopped. So you don't see any duplication because there is no duplication. It's not going any further. It is starting from where it stopped. So no missing data as well. Yeah. So that's the key part from the checkpoint. So it processes only data since the last checkpoint. And the third is autoloader automatically detects new files. Now, you don't need to poll the directory. Yeah. You don't need custom file watchers. You don't need to maintain states about which files you have processed. The autoloader handles all of that complexity for you. It is scalable, efficient, and handles schema evolution gracefully as well. This is your bronze layer pattern, raw data ingestion with minimal transformation. So maintaining full history and optimize it for append-only workloads. The key takeaway here is streaming table for continuous ingestion, autoloader for intelligent file detection, and now you have a checkpoint-based incremental processing, append-only pattern for bronze layer. No manual state management required here. Yeah. Now let us look at materialized views now, yeah, which are used for aggregations, joins, and derived business logic. In this example, we are creating a daily sales summary. Notice the @dp.materialize_view decorator. Yeah? This tells the engine we want a table that is periodically refreshed with the computed result. Now, the function reads from our raw sales table using standard batch read syntax, which is spark.read.table. Then we apply business logic, grouping by store ID, and aggregating the sum of amounts as total sales. This is straightforward Spark data frame code that any data engineer would recognize. What makes this powerful are the three characteristics on the right. Number one is managed state. The engine decides whether to do a full refresh or incremental update. It looks at your query, looks at the source data, and makes an intelligent decision about the most efficient way to update the materialized view. You don't have to write complex logic to determine if this should be a full load or an incremental update. You don't need to do that. The system will do it for you. Now, the second bit is the standard batch read syntax. Yeah, the one we saw before. The standard batch read syntax this is just normal Spark code. No special APIs to learn. No proprietary syntax. If you know Spark, you can write these transformations as well. Yeah. And the third is it handles complex aggregations and logic. You can do joins across multiple tables, complex window functions, multiple level aggregations, whatever business logic you need. The materialized view pattern gives you the flexibility to express complex transformation while the engine handles the optimization. This is typically your silver and gold layer pattern. Yeah? Cleansed, enriched, and aggregated data ready for consumption. The takeaway here is materialized view for business logic, engine managed refresh strategy, standard Spark data frame operations, suitable for complex transformation, silver and gold layer pattern. Yeah? So that's the takeaway. Now, this is again the data quality. This is my favorite one. Data quality is not an afterthought. Yeah, so that's the key part. This is the main problem with all the pipelines before. So, like it's an afterthought. You do data quality after you do the pipeline, after you ingest the data, or so on and so on. But here, the data quality is not an afterthought. It is integrated directly into your pipeline definition. This is one of my favorite features of the Lakeflow approach. Yeah. In the code example, you can see data quality expectation defined right alongside the materialized view. Yeah. Now, you can see data quality expectation there. We have three different types here. Yeah, you have different types, which is declared as or decorations. They're done as decorators now. Now the green path, yeah, which is at dp.expect. This is a warning level, meaning if the condition fails, it logs an error but keeps the data. For example, checking ID is not null. With this decorator means invalid ID will be logged, but those rows will still be processed. This is useful for monitoring data quality trends without blocking the pipeline. The yellow one, on the other hand, is called at dp.expect_or_drop. This is the cleanup level. If the condition fails, it drops the invalid rows, but the pipeline proceeds. Yeah. In our example, we are checking if age is greater than 18. N rows where age is 18 or less will be silently dropped, and the pipeline continues processing the valid rows. This is great for cleaning known data issues without manual intervention. The red path is like at dp.expect_or_fail. This is the halt level. If this condition fails, the entire pipeline stops immediately. We are checking a critical currency is equal US dollar, for example. If any row has a different currency, we don't want to proceed because it could corrupt our financial calculation. The pipeline fails, you get alerted, and you can investigate and fix the source issue. The 2026 update, the Databricks is at the bottom, is significant. Expectations can now be stored. It's very important here from Databricks. Expectations now can be stored and managed in Unity Catalog tables. This means your data quality rules are version controlled, auditable, and even reused across multiple pipelines. You can create centralized data quality catalog that is governed and maintained by your data governance team. The key takeaway here is there are three levels: warm, drop, or fail. Quality rules as code, not separate systems. And the 2026 Databricks update is like Unity Catalog integration for rules, progressive data quality enforcement, automated quarantine, and alerting. Now, let us see how all the three pieces come together in the Medallion architecture pattern. This is the recommended approach for organizing your lakehouse. Like zone 1, like the bronze layer. This is your raw ingestion zone. You are using dp.table here with streaming for a continuous ingestion via autoloader. The data is append only, maintaining complete history. It is the source of truth here. Everything that comes is preserved exactly as received. Think of this as your digital landing zone and historical archive combined. So this is very critical here. I mean, it is the truth, the truth of your data domain. It is a truth because it is a copy of your source. It's exactly a copy of your source. You receive them as they are from the source. I mean, exactly the source. So what it is doing is like you are having a digital landing and also historical archive combined together in one place. So this is the bronze for you. So it is immutable. You don't delete or change or anything on that table. You don't change it. What you do is like you take a copy of the data from the bronze and then you do some work for silver or for gold. So you to take a copy and work on that copy for silver, but don't change the data in the raw or the bronze layer. Zone number 2 is the silver layer. This is your cleaned and validated zone. You are using, as we were talking before, dp@dp.materialize_view and dp.expect for quality rules. This is where you filter out invalid records, deduplicate data, standardized format, enrich with reference data, and create trusted data set. The data here is cleaned, validated, and ready for analytics. This is what most analysts will query the data. So the silver layer is like if there's any duplication, any standardized, you want to standardize your data, the date format, or if you have, like, for example, the naming convention of your, if you want to capital, to start with the capital when names are involved, or if you have any kind of standardization within your organization, and the cleaning of the data, transforming it, everything happens between these the bronze and silver. What you do is like you will have a gate between the bronze. So anything which passes that gate is a clean, validated data. And if it's not clean or validated data, you put it in quarantine. So that's the silver data for you. And then the gold layer, this is your business ready consumption. Again, using dp.materialize_view, but in here you are creating aggregation and metrics that directly support business decisions. This is your star schemas, dimension tables, pre-aggregated KPIs, and analytics ready datasets. So in here, you do data modeling for dimensional modeling, or could be star schemas, so that you'll have a fact table, facts and dimensions, so that will be ready for consumption by the end user. Yeah. So data here is optimized for reporting and dashboard. That's the key part. The key message at the bottom is the DAG is inferred automatically by reading from upstream tables. You don't explicitly create dependencies. If your silver table queries the bronze table using spark.read.table, the engine automatically knows that silver depends on bronze. If gold queries silver, the dependency is automatically established. The engine builds the entire execution graph from these implicit dependencies. This is revolutionary because it eliminates the need for tools like Airflow for simple pipeline orchestration. Again, this is very important here. The Airflow is an interesting bit. Now the Lakeflow is taking most of the Airflow, but there is a couple of things which are in Airflow which are very important and interesting, especially if you are doing troubleshooting. I am just inclined to use it because it has a very graphical interface where you do the troubleshooting, and if there's some problems, you can do there. I don't think that functionality is anywhere. So Airflow is very. The orchestration is okay. The Python code can be done here, but the monitoring side, the metadata which Airflow captures and the reports it generates for you, And then the way you can do like a troubleshooting if there is any problem is very fantastic. I hope the Lakeflow will have the same thing, but it has similar functionality, but the standard is high in Airflow. The orchestration is built into the data definition themselves. So that's the key part. So the key take away from here is like the bronze is raw, silver is for clean, gold is for business, and each zone has appropriate constructs and automatic dependency resolution, separation of concern for data lifecycle, built-in governance, and linkage. I think we need to stop here because it is too long. I will split it and then I will come back for the next session. Bye. Thank you very much for listening.